Welcome back, everyone. In the last video, we learned how we can define our own custom functions in our code, and I mentioned that we had a latent bug in our code. For example, when we prompted the user for an integer using getInt, what if the user doesn't cooperate and enters something that's not an integer? For example, what if they entered the string cat? Well, it turns out that the function getInt is somewhat sophisticated. Somewhere in the implementation of getInt is some code that will check if the user entered an actual integer, and if they didn't, then this function will reprompt the user to enter another number. And that's great. But what about if we entered something like -5? Well, -5 is in fact an integer, however it's a negative integer. And it wouldn't make much sense to print a grid that is -5 by -5. So what we really want to do is get only a positive integer from the user. But again, there is no getPositiveInt function that we can just use. We'll have to define our own getPositiveInt function if we want to ensure that the user will be reprompted if they enter anything other than a positive integer. To accomplish this, we're going to be introducing another type of loop that works especially well for doing this. This type of loop is called a do-while loop. And do-while loops will allow us to perform some action at least once, and then check if a condition is met. Let's look at the syntax of a do-while loop because it's a little different than the loops we've seen thus far. And the syntax for a do-while loop is as follows. We use this keyword do, followed by open and closing curly brackets. And then on the next line, we'll use this keyword while, followed by open and close parentheses. And inside these parentheses, we're going to be checking a condition. So this do block is going to run at least once. And then we'll check this condition. And if the condition evaluates to true, the do block will run again. And then it's going to recheck the condition. If the expression evaluates to false, then we will exit this do-while loop. And I think seeing some examples is going to help you better understand this. So let's just jump right into our Ubuntu virtual machine and start coding this up. And as always, we'll start by opening up the terminal. We'll change directory into our tutorials, and we'll use code, space, and a dot to open up VS Code in this directory. And if you've been following along up till now, then this should start to feel a little more familiar, since we do this every time we start writing some code. I'm going to exit out of this file, and I will save it. And let's create a new file up here. And I'm going to call this one validate.c. And we'll do our normal boilerplate, include stdio.h, int main void, my curly brackets, and my return 0. And so what do we want to do here? Well, we want to prompt the user to enter an integer. But we want to check if they entered a negative integer, we want to reprompt them. Let's first preemptively come up here and include the CS50 header file, because we know that we're going to want to use the getInt function. And now let's make use of this do-while loop. We can come down here in our main function and type do, and if we go to the next line by hitting enter, we can see that our text editor will autofill some of this for us. And it's saying that we should put our condition down here in the while part, and we should put our code in the do part. So let's do our code first. Right here, we just want to prompt the user to enter an integer. And we know how to do that. We can use getInt and just prompt the user. We can say enter a positive integer. But now if we want to do something with the value that we get from the user, we need to store it in a variable. And it turns out that due to something called variable scope, which we will learn about in depth in later videos, we have to define this variable outside of this do block, similar to how we defined our counter variable outside of our while loops. So I can come up here and I can give this variable of type int the name number. But I'm not going to give this a value yet. And this is totally fine. I can just use int number followed by a semicolon to tell the compiler I want a variable called number, but I'm not assigning a value to it just yet. And now down here in my do block, I can assign the value the user enters when prompted and store it in this variable. I can just say number is equal to getInt. And again, this is going to work from right to left. It's going to prompt the user for an integer, and whatever they enter is going to be stored into this variable called number. Notice though that I don't have to use int number down here in my do block. I can just access this variable using its name. You only have to put the data type in front of a variable when you're first defining it, like this on line 7. So this code is going to initialize a variable called number of type integer, and then this do block is going to run at least once. We're going to prompt the user and ask them to enter a positive number. Whatever they enter is going to be stored in this number variable. And then we want to check a condition. And what do we want to check? We want to check if the number that the user entered is less than 0. In other words, if they entered a negative number. And if that is the case, if this evaluates to true, then we want this do block to run again and re-prompt the user for another number. And only when the user enters a number that makes this expression evaluate to false will we accept their input and exit this do while loop. And this can be read like do the following while number is less than 0. So let's go ahead and save this. We'll open back our terminal and let's compile this. We'll use gcc-o validate.c. And then since we're using the CS50 library, again we have to use -l CS50. And we see that we get no errors. So let's go ahead and run this /validate. And let's try entering a negative number, -3. And we see we're re-prompted for another number. Let's enter cat, and we're re-prompted again. How about -5? Nope. And let's finally cooperate and enter a +4. And we can see that our program accepts that and just exits, because we haven't written any code that tells us what to do with this number once we get it. But we can see that our program is working as expected. So now that we've seen how we can use these do while loops to validate user input, let's try to design this a little better by implementing our function called getPositiveInt, which will get a positive integer from the user. We can start by coming down here outside of main, and let's think about this for a second. We know that we want this function to be called getPositiveInt. We don't need this function to take any inputs, but we want it to hand us back a positive integer that the user enters. So for the input, we can type void, and the return value is going to be an integer, because it's going to hand us back a positive integer. Now we can open up our curly brackets, and we can basically do the same thing that we did up here. We first initialize a variable of type int, and we'll call this number. and end this with a semicolon. Now we can do our do block. And what do we want to do? Well, we want to assign number, the value that we get back from getInt, and we'll prompt the user to enter a positive number. And we want to do that while the number that the user enters is less than 0. And then finally, we want this function to hand us back or return to us this number variable. And we can do so by using the return keyword, and we can just return number. Now this function is complete, but remember we have to copy this function prototype and paste it above main with a semicolon so that we have access to it in our main function. And we can go ahead and erase this from earlier. And to use this function, I can type its name, get positive int. It doesn't take any input, but again, this function returns a value to us. And if we want to do something with it, we're going to need to store it in a variable. I'll call this one positive number, and it's going to be an integer, of course. So this line is going to get us a positive integer and store it in a variable called positive number. And then after we run this get positive int number and get a positive integer from the user, let's just print that out. And we know how to do that with printf. We can just say you entered and then %i for an integer followed by a new line, and we'll pass in positive number. And this with a semicolon. Now if we save this, come back, recompile, rerun, let's try entering -3 again. Let's try entering cat again. How about -5? And finally 4. And we can see it accepted 4 and it says you entered 4. So this has been do while loops, and while the syntax is strange, just understand that this is yet another building block that you have in your tool belt now to solve problems. And do while loops are great if you want to do something at least once and then check a condition. These do while loops are especially useful for validating user input, such as in our example. And this is a common theme that you'll encounter in programming. We often want the user to enter some information, and we'll perform actions on this information. However, we never want to count on the user to follow our directions. We should build our programs to be defensive and to catch these corner cases, such as if a user enters something invalid. And these are the things that hackers will try to do to manipulate our programs. If we didn't have this check in place, then entering a negative number will essentially break our program. For example, if we wanted to use this number that the user entered and pass it to a print grid function, then how can we print a grid of -5 by -5? It's not possible, and consequences will occur. So these corner cases that we don't account for are known as bugs, and they can be exploited if we're not considering that a user may not cooperate properly. But before I end this video, let's re-implement the print grid function and pass this return value of this get positive int function to our print grid function. And I'm going to do this sort of fast because we've already covered this. I'm going to come down here outside of main, and this function is not going to have a return value. We're going to call it print grid, and it's going to take as input a single integer. We'll call this size. We'll open up our curly brackets, and our outer loop will be for int I is equal to 0, I is less than the size, I++, open more curly brackets, and we'll do our inner loop. We'll say for int j is equal to 0, j is less than size, j plus plus, open up more curly brackets, and inside here, we just want to print out a single hash, and then after this loop completes, we're going to want to print out a new line. So again, this is the same code that we wrote in the previous example, and I'll copy this prototype up right here and end this with a semicolon. So now inside main, I'll first prompt the user for a positive integer, just like we have. And then I can call this print grid function. I can say print grid. And what do we want to pass as the argument to this print grid function? Well, we want to pass the positive number that we just got from the user. And now if I save this, open my terminal, recompile, rerun, and let's try entering a negative number like -5 and -3. We'll try entering nothing at all. How about cat? And all of these seem to be caught by our logic. How about I enter 3, and when I hit enter, and you see we get a grid of size 3. Let's run this again and enter 5, and we get a grid of size 5. So there's one final thing that I want to show you in this video, and that's what are called comments. We can add comments to our code by using the // syntax. And comments aren't real code per se. They won't be executed, and the compiler is just going to ignore them. Comments are really just for the human. We can use them to explain what some part of our code is doing. And what many programmers will do when they're starting a program is to think it out in pseudocode and use these comments, and then start working on each smaller piece. For example, if we were tasked with writing a program that gets a positive integer from the user and prints a grid of that size, but we weren't really sure where to start, it's more than reasonable to write this out in pseudocode first. So let me go ahead and erase all of this. I'll erase everything in my main function, and I'll erase my prototypes. So if I was just starting on this program, I could start by writing some comments. The first step would be to get positive int from the user. And then the next step would be to print a grid of that size. And now this program is implemented in pseudocode. And I could even go as far as assuming that I'm going to implement a function called getPositiveInt. And this function is going to return back to me an integer, and I'll just call it number. And now down here, I can assume that I'm going to implement a function called printGrid and pass to it the number variable. Now there's still work to do. These functions don't exist yet. It's up to you to implement them, but now we have this starting point. We can now think about how we can implement a function called getPositiveInt and return to us an integer. And then we can think about how we can implement a function called printGrid that will take a number as input and print a grid of that size. And I think with this, you might be able to see how we can break up a program into many smaller pieces so that teams of people can work on different parts of it, as long as they all decide what these inputs and outputs should be. And you'll start to see comments more and more. Comments are a sign of good style, and they make our programs easier to read, especially after coming back to a program or a project after a couple days or a couple weeks and trying to understand what it's doing. And we also saw an example of a comment when we typed do and hit enter. These are an example of a multi-line comment. If we use this / and star syntax, we can write comments that span multiple lines. So I can say this is a multi-line. I can type comment. And this will be ignored by the compiler. So at this point, we've covered a lot of different topics, such as variables, loops, conditionals, functions, and much more. In the next video, we're going to look at something called an array, which is another data type like strings, ints, and chars, but arrays are a little special. They're not primitive data types per se. And again, a primitive data type is a piece of data that can only store one value, such as int. Ints can only store a single number. Arrays are a data type that lets us store multiple values. For example, we could use a single variable to store x, y coordinates, or we could use a single variable to keep track of a bunch of different scores from a game. And we'll see these in depth in the next video. So thank you all so much for watching, and I hope you got a lot of value from this video. If you did enjoy, make sure you hit that like button so that I know you want to see more content like this in the future.